So we have the product rule, which is how we take the derivative of a product of two functions if we're multiplying two functions. Now we're going to talk about the quotient rule. How do we take the derivative if we're instead dividing two functions? So here we're going to have y equals t of x for the top part of our fraction divided by b of x representing the bottom part of our fraction. Then the derivative y prime is equal to b of x times t prime of x minus t of x times b prime of x divided by b of x squared. And I know what each and every one of you is thinking right now. You're thinking, why, but of course. It was so obvious. How did I not see it? It was in front of my eyes the whole time. No, you're thinking, boy, that's really long and obnoxious, and I don't really want to memorize that. So we can shorten this up a little bit. We can say b times t prime minus t times b prime divided by b squared. We could use this version, but I don't know. I still thought that was too long for even me. I don't think memorizing this is especially easy. If that's a formula that works for you, if you can remember that and it works for you, by all means continue to use it. But I have a fun rhyme that I say to myself pretty much every time I do the quotient rule. It goes low, d high, minus high, d low, square the bottom, and away you go. Here's your quotient rule. Now, it sounds silly if you say it out loud to yourself, but if I get the right answer, I don't really care. So when we say low right here, low, that's the bottom part of my fraction. That's this guy right here. When I say d high, that really means the derivative of the numerator. So that's the same as the derivative of the top part of my fraction. Minus high, so that's my numerator again, that's t, the top part. D low, that's the derivative of my denominator, that's b prime. Square the bottom, well, we square the bottom, that's b squared. And away you go. So it's one of those fun rhymes that, again, I think it makes you feel silly as you say it out loud to yourself. But I have never once forgotten the quotient rule since I've learned this, and I don't want to disappoint my communications colleagues here, so I will make sure to cite my source. This comes from my AP calculus teacher, Mrs. Schneider. Thank you, Mrs. Schneider, wherever you are, for teaching me this awesome, fun rhyme for the quotient rule. So let's actually go and practice using the quotient rule now. Oops, I'm going to leave this right here just so that we have it for reference. So this is the high part. This is the low part. And actually, let's color code these again. I think that works out well. So this is high. This is low. When I go to take the derivative, if I'm doing the quotient rule like I am here, when I take the derivative using the quotient rule, I oftentimes won't even write out what's t, what's t prime, what's b prime. I just say this whole thing out loud to myself as I go, and it kind of acts as a set of directions. So when I say low, that's the denominator. So low, that is 3x squared minus 5. D high, derivative of my numerator. So the derivative of x cubed minus 1, that's going to be 3x squared. Minus high, so that part, my numerator, that's going to stay the same. So x cubed minus 1 high. D low, derivative of my denominator, so the derivative of 3x squared minus 5. So that's going to be 6x. Square the bottom, 3x squared minus 5. And away you go. So we set this problem up, which is only half the battle, because we do have quite a bit of simplifying that we can do here. Quotient rule is not only a little bit longer than the product rule, it is just, there's more algebra involved after the fact, so we need to be careful. So for the first terms, I don't think it's too bad. I'm just going to take this 3x squared and distribute that to each term. So let's do that. Oops. So this will be 9x to the fourth minus 15x squared. That second term, we're going to have to be really careful because I want to distribute this minus sign and I want to distribute this 6x. So I would recommend for right now, I would recommend you do those one at a time. I highly recommend starting with the 6x. I'm going to take that and distribute there, and I'm going to continue to use parentheses. So I'm going to say minus, open a set of parentheses, x cubed times 6x, I have 6x to the fourth power, minus 1 times 6x, that'll be 6x, divided by your denominator. I'm going to tell you right now, do not ever worry about foiling that out. We can always keep that as 3x squared minus 5 quantity squared. From here, there's just one more thing I need to do. I need to distribute this minus sign to each of these two terms. The way I do that is I change this to a plus, and I change both of the signs on the terms that are inside of the parentheses. After that, if you can combine like terms anywhere, go ahead and do that. I see 9x to the fourth and negative 6x to the fourth. So I have 3x to the fourth power minus 15x squared plus 6x, all divided by 3x squared minus 5 quantity squared. Here is my derivative. If you wanted to, I'm looking at that numerator right now, I do see a common factor of 3x. So I guess if you wanted to, you could say 3x times, that would leave me with x cubed minus 5x plus 2 divided by 3x squared minus 5 quantity squared. We could write it like that as well. But to be honest, I always think that the quotient rule problems are long enough. Unless you gain anything substantial by factoring, I'm generally not going to worry about it. So especially for a problem like this where all we want to do is find the derivative, I probably won't worry so much about factoring. So that's it. So we need to be careful both in the setup and in the simplifying here because there's a lot of different ways that these problems can go wrong. So we just need to be really, really careful. Let's look at another here. C, or B, I guess in this case, I have y equals 2 over 5x squared minus 25x plus 10. So again, you can label this off to the side if you want, but I'm just going to jump right in. My product rule says low, so that's my denominator. So low, that's going to be 5x squared minus 25x plus 10. D high, derivative of 2. What's the derivative of 2? That's a constant. Derivative of any constant, 0. Minus high, that's 2. D low, derivative of my denominator, so the derivative of this guy, of 5x squared minus 25x plus 10, I'll have 10x minus 25 divided by 5x squared minus 25x plus 10 quantity squared. Now notice here I've got this whole thing right here times 0, right? Anything times 0 is just 0. This whole first term, so to speak, is going to drop off. I just need to take this minus 2 and distribute that to each term in my numerator. Oops. So we'll have y prime equals negative 20x plus 50 all over 5x squared minus 25x plus 10 quantity squared. And again, we could simplify that more. We could factor it a little bit. But honestly, once you simplify that numerator, you kind of distribute, combine your like terms in your numerator. That's all I need to see. I don't need to see you progress any further in this problem. So there is our derivative. A couple more here just to practice. Here I have f of x equals e to the x divided by x cubed minus 8. So all right, let's take our derivative, f prime of x. Low, so that's my denominator, x cubed minus 8. D high, derivative of e to the x. Well, the derivative of e to the x is just e to the x. Minus high, that's e to the x. D low, derivative of my denominator, that will be 3x squared. Square the bottom, x cubed minus 8 quantity squared, and away we go. So here I can take this e to the x, I can distribute it to both terms on the left-hand side. I'll have x cubed e to the x minus 8e to the x. Minus over here, I'm just going to flip these around just because we normally write the exponentials last. I don't know why, we just do. So minus 3x squared e to the x divided by x cubed minus 8 quantity squared. Just like last time, if you wanted to, you could factor out an e to the x from each term in your numerator if you really wanted to. I don't think it makes that much of a difference here for this particular problem, though. So I would just probably say, you know what, here's our derivative. Let's call it a day. Lastly, here I have y equals 4x divided by 2 plus natural log of x. Let's take a look at this example. I want to take the derivative, y prime. So I'm going to have to use the quotient rule. I think, before I jump in here, I think figuring out when you need to use the quotient rule is a lot easier than figuring out when you need to use the product rule. That's kind of one benefit of the quotient rule, is anything that looks like a fraction, any rational function, so anything that looks like a fraction, that's when you're going to use the quotient rule. So that looks like a fraction to me. If I kind of scroll backwards, this looks like a fraction to me. This looks like a fraction to me. This looks like a fraction to me. So it's a lot easier, I think, to determine when we need to use the quotient rule, but it is, it does tend to be a little bit longer, as we've seen. But let's go ahead and use our quotient rule here. Y prime, we'll say low, so that's going to be 2 plus natural log of x. D high, derivative of my numerator, that's going to be 4, minus high, that's 4x. D low, derivative of my denominator, derivative of 2 plus natural log of x. Well, the derivative of 2, that's going to be 0. Derivative of natural log of x, that's 1 over x. So you could write it as 0 plus 1 over x if you wanted, or you could just say 1 over x. Square the bottom, 2 plus natural log of x squared, and away we go. So I can simplify the numerator just a little bit here. Let's go ahead and do that. Let's see, we'll distribute the 4 here. So 4 times 2, I've got 8, plus 4 natural log of x, minus over here, when I multiply 4x and 1 over x, my x's should cancel, and I'm left with just minus 4. Denominator going to stay exactly the same, 2 plus natural log of x, quantity squared. Combine our like terms, we've got 8 minus 4, I've got 4 plus 4 natural log of x, divided by 2 plus natural log of x, quantity squared. So I would definitely recommend practicing the quotient rule. It's a little bit more difficult than the product rule, I think, but it is easier to pick out when you need to use it, because when it comes time for a quiz or an exam, I will not be telling you use the product rule or use the quotient rule. In the end, it's going to be up to you to decide when you need to use the product rule and when you need to use the quotient rule.